All right, before I teach you guys how to factor by grouping, which is the next video that you're going to be watching, I want to talk about a piece of factoring by grouping that you're going to need to understand in order to understand the entire concept of factoring by grouping. So I just want to go over 3 examples where we're going to be given 2 terms, and we don't want to just find the greatest common factor that may be a number or a variable or a combination of a number times a variable. We want to look at where we have a common expression. So we are typically going to be factoring out an entire binomial as opposed to factoring out a monomial, which is what we're used to. So if I look at this first example here, notice that my terms are separated by a plus or minus sign. So I have 1, 2, 3 plus signs, which might initially make me think that that must mean 4 terms. But because there's multiplication here between the 3x and the 2x plus 1, multiplication trumps addition. So this is considered one term. This is considered a monomial, where I'm multiplying this by this. This is considered one term, where I'm multiplying this by all of this. So in reality, I only have 2 terms being separated by that plus sign there. My first term being 3x times 2x plus 1. My second term being 7 times 2x plus 1. So I want to determine, or I need to find out, what do these 2 terms have in common? Well, notice they both have not just a 2x or not just a 1 in common, but the entire binomial 2x plus 1. So just like when we factored out GCFs before, I'm going to take that binomial and put it out front. Because it is already in parentheses, I'm going to keep it in parentheses to show that it was originally grouped together as a binomial 2x plus 1. Then I add my next parenthesis, just like I have before when I've taken out GCFs, and I ask myself, from this first term, if I take the 2x plus 1 out, what am I left with? Well, I'm left with a 3x. From the second term, if I take a 2x plus 1 out, what am I left with? Well, aren't I just left with a plus 7? And if my goal of factoring is to get a multiplication problem, have I indeed taken 2 factors that were being added, or 2 terms that were being added, and now have just a multiplication problem where I have 2x plus 1 times 3x plus 7? Looking at my second example, I want to do the same thing. Notice it's set up very similarly. I have this x times 5x minus 1 subtract 2 times 5x minus 1. So notice once again, there are only 2 terms being separated by that single minus sign. My first term being this x times 5x minus 1. My second being this minus 2 times 5x minus 1. So if I ask myself, what does this term and this term have in common? Well, they have a 5x minus 1 in common. So I'm going to take that entire binomial and put it out front, keeping it in parentheses, and ask myself, now that I've taken that GCF out, what is left of my parentheses? Well, when I take my first term, x times 5x minus 1, and take the 5x minus 1 out, I'm left with x. When I take my second term, and I take the 5x minus 1 out, I'm only left with minus 2. Again, my goal of factoring is to get a multiplication problem. Notice I now do have 5x minus 1 times x minus 2, so I have reached that goal. Looking at one more example, this one will be a little bit different because we're going to see what happens when we don't have a common factor initially like we have in the other 2 examples. So I'm going to start by determining how many terms I have, and I do have that minus sign in between, so I have this term here and this term here. And looking at them, I notice that this one has an x minus 1, and this one is super close. It has a negative x plus 1, but they're not exactly the same. However, I do know that x and negative x are related because they're opposites, and that negative 1 and positive 1 are related because they're opposites. So what would happen if I took a GCF of negative 1 out of here? Well, if I take negative 3 times negative 1, don't I get its opposite 3? If I take negative 10 times negative 1, don't I get its opposite 10? If I take negative 8 times negative 1, don't I get its opposite 8? So if I need these to be the same, and right now I have opposites, if I factor out a negative 1 from either of them really, but I'll do it from the back one, I should be able to obtain the same thing. So I'm going to go ahead and leave the 4 times x minus 1, leave the minus 3, and remember when I factor out a GCF, I pull it out front, I'm going to put the negative 1 in parentheses to show that it's negative 3 times negative 1 now, not negative 3 subtract negative 1. When I take the negative 1 out, negative x divided by negative 1 is x. Positive 1 divided by negative 1 is minus 1. I'm going to go ahead and multiply these together, giving me 4 times x minus 1 plus 3 times x minus 1. Now, my two terms have that common factor of x minus 1. So I'm going to take that x minus 1 and pull it to the front. When I take an x minus 1 out of my first term, I'm left with 4. When I take an x minus 1 out of my second term, I'm left with 3. From here, I could also, if I wanted to, combine the 4 plus 3, giving me x minus 1 times 7. I guess I didn't realize it's kind of an awkward problem that I made up, that you could do that. I should have put a variable by either the 3 or the 4. But the concept still remains the same. This is going to be one of our in-between steps. We are going to have a couple steps before we get to this point when we do factoring by grouping. So like I said, I just wanted to give you a heads up in terms of part of the process for factoring by grouping.